trying to set up for a confined space rescue, there are a lot of like one-time initial setup tasks, and it's like organized chaos. So it's really important that the person in charge has a firm grasp on all his minions running around, because everybody wants to help and everybody wants to go, but sometimes you have to take a step back and just stop, wait, get clarification. This mat right here, this green mat, this is our hole, basically. This is a cover on a hole, and this is the entry into the confined space. So, of course, our attendant is manning, is guarding it, not denying entry until we're full on ready to go. And so, like, the two big things to set up are always airlines and communication lines. And it's really important to kind of nail down where exactly you want to set them up, and what direction from the space, the entry into the space, and how far away. Because once you lay it out and you start deploying communication lines, airlines, hose lines, that sort of thing, and then you realize that you need to change positions, trying to move all that stuff on the ground, it becomes a nightmare. We want the priority for airlines, because the airlines that we carry are 100 feet long. If we need to utilize that to the best of our ability, so the closer the better. And the more direct, straight shot into the entry, the better. So if we have to round corners and things, we don't want that. The comm system should be relatively close, but not as close as the air systems. They can be off to the side somewhere, but we don't want those two systems to be stacked on top of each other, because there's a lot of things and a lot of clutter. From what direction are entrants coming into the space from? That's going to dictate where we should kind of set up the box, the SABA system, the supplied air respirator system. That has implications for the rigging team, especially if we're building like a tripod or a vortex, so we'll have to coordinate with them as well. The supplied air respirator system that we use is called SABA. Air Systems International is the company, Mach 3, whatever, that's the type. But if you look at the whole kit on the ground, like, this is for 4 rescuers or 4 entrants total, and air supply for 1 victim. So if you look at it, it's quite a lot. It takes up a lot of space. Each one of these is 100 feet long, at least for the rescuers or the entrants. And then we have an additional 100 feet of line spare. We need to have an idea of how far we need to go into the space before we even plug things up, because if we know we need to go 150 feet and we're only hooked in and we're rolling and our entrants are in the space and they need more line, that's a problem, because in order to give them more, they have to come out of the space, and then we have to go off air, reconnect, because we don't want to take away their breathing supply while that's their only supply. So they have to come out. So we need to kind of eyeball that or gauge it or have a good idea. So OSHA limits airlines to 300 feet max. That's a topic for another day, but we do have the ability to go 300 feet with additional units that come in to support us. These hoses are actually a bundled package. So we have the air supply as well as the hardline communications lines as well. So 100 feet of that too, right out the gate. Anything beyond that, they're standalone. So if we need to go additional 200, 300 feet, it's separate hose lines and separate comm lines that are not bundled. These things are typically packed. Sometimes people will coil them, which is really bad, because when you deploy them, if you just stack a coil and you want to deploy it, it creates these kinks and twists. So other people will coil them and package them and alternate the coils, and it'll eliminate that problem. The downside, or the problem with even doing that is you don't know at glancing at a package as it comes out if they were coiled correctly to avoid the kinks and the twists, or if they were coiled incorrectly. You don't know. So as a best practice, when we're kind of getting our site set up, it's good to assign more than one person initially to just setting up the air systems, because we need to coil all these, and if we do it in a figure 8 pattern, it guarantees that we will not have this coil effect and twisting and kinking effect. So take the extra time on the front end to flake everything out in like a figure 8, nice and neat. It'll save you time on the back end and frustration. We labeled it up as up because it's very heavy, where you would normally think to open the lid, so it's actually upside down, so this side up. When we open our kit up, all right, we have the ability to put in 4 bottles. They can be the 60-minute or the 45. It doesn't really matter. We can do quick connects or traditional threads. So 4 bottles of supply. Also for supply, we can put in a high pressure inlet right here. So for continuous airflow from like a compressor or something. So right in here, that's an option. If we're close by to that source, we can do that. Otherwise, we're gonna be doing bottles, and it's gonna be basically a cycle of exchanging bottles. Each line, first thing I wanna do is close the bleeder valves on all 4 lines. Just as a good habit to get into. Since these lines, if you see, like this will work for the classic screw-on, but it doesn't work for, in a pinch, if you had a 45 or 60 that had a quick connect, but we can adapt that. We have 2 of these adapters in our kits, and so we can just thread this in. Okay, so we've connected all 4 bottles, 2 bottles on one side of our system for a pair of entrance. So team 1 has 2 bottles between the 2 of them. Team 2 has 2 bottles between the 2 of them. All our whip bleeder valves are closed, and I don't want to open up everything right out the gate. So let's walk through with these lines as we go in and talk about the pressures that we're looking for. 65 to about 125 PSI is kind of the operating range for breathing air. It's somewhere in that range. We've kind of put a little sticker on it that says 110 PSI when we set it to regulate. That's just a general rule of thumb. Ultimately, it's going to be how do the entrants feel? Like, are they having to suck more air in, or is it too much air? And we can fine tune that. But as a standard default, like somewhere in 100, 110, you can just go 110 right out the gate. And to make it easy, we also put a tick mark with a black marker on our regulated pressure coming out. So just standard regulators. The dial on the right is the bottle pressure, and the dial on the left is what we regulate it to. So let's look at the 2 halves of our system. So here, it's open between the 2, so air can flow directionally between the 2 halves. So as a best practice, general rule of thumb, I isolate the 2 halves. I put team 1 here and team 2 here as the backup team. So we separate out one system, or one team, and this is the regulator for that team. And then the other team, team 2, and this is the regulator for that team. We aren't gonna worry about this or this. This will match the outlet regulated pressure. These 2 will match, and I adjust it here. So 4 ports for team 2, 4 ports for team 1. Turn it on. And now I adjust my outlet regulator pressure. So this is all initial sequence for team 1. Now I adjust my pressure to 110. And team 1 is ready to rock and roll. Let's repeat the steps for team 2. So again, I make sure that my whips are closed. I turn on any bottle, doesn't matter which one. My gauges go up. And when I set this regulator pressure, this one will go as well. So I want to make sure they match. So it should be 110. It's harder to see 110 on this dial. This dial is a little bit easier to see. When I start setting it, I adjust it. So I'm at 80, a couple more turns, quarter turn there. That should give me about 110. So my team 1 entrants are ready to go. I double check, just tweak that just a little bit right there, 110. Okay. So we're ready to go for team 1. And then team 2, I can do the same thing. And we're ready to go for team 2. Team 1 is breathing off of 1 bottle, so they're sharing. So I have to watch the pressure. Once I get down to about 500, that's my indicator that I need to make a bottle switch or exchange. And it's pretty easy to do. The golden rule is don't take away until you give something first. So give them air before you make a disconnect. So we already have our second bottle that we aren't using ready to go. So we're set. Usually with when we do RIT, we have that RIT bag and we do a universal quick connect, or the bottles equalize. Not the case here. So if we go up and put both of them on, if one of them's at low at 500 and I turn the other one on, it will not equalize. It will not backflow and start filling that bottle. There's a check valve in here. At the moment, they're still drawing from both tanks, and I can then disconnect or just bleed off on the whip. So close the bottle, bleed off on the whip, on one while the other one's still flowing. So I shut down, bleed the whip, and then I can replace the bottle. And then when it's time for this one to get changed out, this one is ready to go when I start her up. So that's just bottle exchanges. You can imagine that, like, well, if this is where I have to plug in my communication system, it's right on top of my air system. So we want to separate it out, but in the same kind of geographic quadrant, and kind of make everything flow into the point of entry, wherever that may be. So this is where we put jumper communication lines in to our air systems and then route them around all this mess to our comm setup. Okay, so when we open up our Savox Hardline comms kit, we kind of package it in kind of a very specific way to try to make it as user-friendly as possible. Immediately, prepackaged bags, these are going to be for our entrance. These are the throat mics and the headsets, and then the talk. So when we get on, somebody's assigned to comms, they open it up. Where our entrance, here you go, entrance, go to work, have some help, don your PPE. C batteries inside here. We have tools that open this up, but I keep this loose and this is loose. Just because, like, if we leave batteries in here that go unchecked, well, they could die. So we store them with the batteries out. When it's time to rock and roll, we just take our tool, unscrew this, pop it out, put the batteries in, and tighten it up, and then we're good to go. Team 1, Team 2, just like military communications equipment, you match up the orange dots. And if they're struggling, you can always spit on it in a pinch. Okay, so I want to direct this that way, or even maybe slightly around, because I'm going to put my jumper lines here. Basically, the direct link is going to go to the end of those bundled packages for the airlines. The talk box is an option. It's a feature. You can use this for a lot of different things. It has a range of about 30 feet. I want to make sure that I have the ability to have the switch. By default, we have it muted. If you push and hold and lock it, that's mute. So we can hear what goes on when they're talking to between the attendant and the entrance, but they can't hear us. So I depress it, let it ride. So zoom in here, zoom in on this. This is important. So it's undepressed, it's out, it's open, it's free flow communication. Like, I can talk into this, they can hear. By default, I push it in, slide it, it locks, it's on mute. I can hear what's going on in the space, but they can't hear what's going on outside the space if we put this outside. A good place for our talk box is to put it close to our airline manager over here, so he can kind of hear what's going on with air supply and stuff. It's just an option. It's an easy thing to do. Our attendant is the only person that really should be talking to the entrance, not the RO. So our attendant by default on the headset has an integrated mic. Same thing, I can mute or not mute at will. We connect in where it says operator, the top one that says operator. Okay, we can put this some distance away from the space. We can get away with that because, I don't know, like 50 feet or so of cable, where we can set this back and have the attendant at the space. Makes it really easy. Okay, there are no more ports to connect to, so we have this thing here, which is for, we have it rescue officer, or RO, rescue officer. This one doesn't have its own mic clicker, muter, on the headset, but we pigtailed it on. So if you look, so the line coming in, we pigtail it, so it gives them the option. But if we're using the talk box, this is out of play. We can't use this. They do make a two-way splitter that you can put right here on the talk box split. So if we put a two-way splitter right here, so two-way splitter right here, we can have the talk box and the attendant as well. We don't have that in our kit, but it's an option. Batteries for the talk box and the command module, C batteries, 3-piece, labeled in the bag. For the talk box, they don't make it easy, Savox doesn't, because the batteries are actually inside. So when we package it up, it's good to kind of leave this really loose. I don't want to unscrew this all the way because the screws will get lost, but if I leave it loose, it's an indicator, and then we say install C batteries prior to use. So we have a screwdriver in there, we just take it off, put the batteries in, screw it back on. We have a whole bunch of additional comm line, and so this can be for, we can go direct if we want to use the Hardline comm system, but we don't need to be on the the SAR or the SABA. That's what this is for, and it's for the jumper. So we're gonna jump. Setting this stuff up is like a cardiac arrest code, running a code. There's a lot of tasks to do up front, and then once you get in the flow, it's a little easier to manage. If I can run this in a way that bypasses the entire site and take all this and go around everything, and then hook in from this direction where my bottles are, that's gonna help facilitate that. So take the advantage of the full length of your cable, route it in a huge horseshoe and bypass, and come in as if the comm system were over here. And now we come in, and now we jump, and we hook in, right here. And we do that for all 4 entrants. So you can imagine that we have 4 long cables. I don't want all those 4 cables coming directly in where our hoses are. I want them to bypass. On is on, turn it on. Adjust the volume for the operator or the attendant. Operator is the attendant at the space. And then we have the talk box volume, and then volume for team 1, volume for team 2. And then I can listen to both of them. If they're both inside the space at the same time, I can isolate one team or the other. So this noise reduction button is if we're doing tool work, so drilling or whatever, it'll cancel out the ambient noise. So as they're doing work, if I'm the operator or the attendant, or if I have help, I can say hit the noise reduction button, push and hold until I'm satisfied. It'll wash out that ambient drilling or tool work noise. That's all that does. We also have kind of like a talk box, but for like when we drill holes, we can pigtail this and make it like a talk box, and then we hook in a line, and then we can lower this down into a space through an opening. We can also take this part off and put in a different attachment. This is for a pole. So if we want to just move this through a horizontal space on a pole, we can do that. So same thing as a talk box. Confined space, we do the kind of like Swiftwater, the reach, throw, row, go kind of approach. We can reach, throw a line to them, get them out. They can get them out themselves or hang on. And then the go is the entrant. That's like the most complicated. And then we can build upon that complexity by putting all these hoses and lines all on the ground. So setting up the right place of operation is key. And that is kind of like rope rescue. You identify the fall line. Like we're trying to identify the fall line that we can't change, we set it, and then we go from there. Now we're kind of segueing into PPE for the entrant. Do we have to use hardline comms? No. Like we have radios. If we can do that, yeah, that's an option. Do we have to use the SAR system? No. I mean, if we don't have to use anything, well, if the atmosphere is fine, then we won't use anything. If we're gonna do some tool work maybe, or there's some particulates, maybe just a half mask is all that was required. If the space is large enough so that we can get in with an SCBA and we can do relative work on a single tank for a rescuer, then we're more than familiar with our firefighting SCBA. That's an option for air. So let's segue into PPE for an entrant in a confined space. What does that look like? Just depends on what the condition is, what kind of space it is, what we're doing. By default, I mean, heavy rescue, we have these jumpsuits, but maybe we need some sort of Tyvek suit for splash protection. Maybe we're going into something else. I don't know, maybe we even need a dry suit, maybe some sort of water thing where we need a dry suit. So that just depends. It's probably a good idea to have steel toe boots or composite toe boots, protection for your whole body, so long sleeve clothing, Nomex, fire resistant, whatever, knee pads, elbow pads, a harness, which is a requirement. We can get into OSHA regulations, so you need a harness. A Nomex hood if you're going to be doing some sort of grinding, cutting. Proper gloves for the conditions. Some sort of head protection, helmet, hearing protection. Eye protection if you're not using like a full face mask, and then lighting. So let's put all this stuff on and see what it looks like for an entrant, full on, suited up for entry with the Hardline comms kit and the supplied air respirator. All right, so every one of these pre-built bundled air comm line hose packages comes with its own harness, regulator, escape bottle, and this is actually pretty important. The way these things are pre-rigged, and we labeled them too. Colors with electrical tape, and also we say put on the right hip. That's really important because you'll see people wanting to reconfigure all this. And the reason why it needs to go on the right hip is the way the hoses kind of naturally wrap around your body and where you can access the connections and where you can view the gauge on your escape bottle. So if it goes on my right hip, I put it over my left shoulder and I size this up. A note on stuff on your harness. You don't want to have a lot of carabiners and a lot of excess stuff that you're not going to use lingering around on your harness because that could get snagged on things. So if you kind of pre-rig your own harness with rope rescue equipment, just get rid of that. I keep some rope rescue equipment in a pouch so that I don't have things hanging off. If this is a problem for space-wise, I can just ditch the pouch too. Okay, right hip. The tether this is where I hook in my airline. This is important too, where I connect this tether. All of our kits, the tether's connected on the back hook instead of the front hook, and the reason why it is that way is because if this gets pulled in any direction, it won't kink close to the inlet. If I put this tether on the front over here, it will tend to bend and pinch that. So the kits are stored this way. If you see it any different, please correct that. It's a one-way check valve, so if I turn this on while I'm on air, I won't equalize. The air in here will not flow back into the system. So turn it on. Flow air. Okay, it flows. Check complete. Put that back in. Close it up. Bleed it off. So I need help with the throat mic. So I want this to be really snug around my neck, but I don't want it to choke me out. And I found that the way that the cords kind of run, I think left side of the neck and the divot off the side of the trachea is probably that most ideal spot. Here you go, Jeff. Go ahead and zip me up. A little mini tether that I can use, and I can put this anywhere just to keep snags or help reduce snags. So I can just put that right there, that's fine. If I'm not using the Saba and I don't need to go on air, I can use a little head harness that I just put on. So head harness, put that on, and then I hook my mic in, and then I wear my helmet, and that's fine. I can't use this if I'm gonna use the face piece of my SCBA because it interferes with the seals. In that respect, I'm gonna ditch that, and we have these little adapters that go on the face piece themselves. The mic, or where you actually hear and connect to the throat mic. This is important because if these things tend to be pre-rigged inside here, you can't see which side you're supposed to use. So it's worth a double check. The brand Savox should be on the outside like that in your harness. So this is the harness for the face mask. So let's rig that up. I'm gonna have Jeff put this on me afterwards.
Okay, so he's going to attach it to the straps here.
Two Velcro straps.
Cool.
You can disconnect to connect to the head strap.
Okay, now we need to connect the throat mic. Okay, so that's set. If I need to do cutting or hot work, I can put my Nomex hood on. So let's do that. I'll protect my head. Helmet up. Air. Toms.
So the connections for air, if my bundle lines get tangled up or snagged, I don't want them to start pulling on my connections. And so we have options to kind of create like a jumper so that it doesn't pull on those all important connections. You can do one or the other, it doesn't matter which, or you can do both. We can use a little snap hook or snap link to hook in anywhere in our harness, or we can just make one with any kind of cordage. You can press it around, girth it around, use a carabiner, and I can connect in anywhere in my harness that will accommodate that. It doesn't matter. If this gets pulled, it doesn't pull my comm connection or my hose line. And then the all-important retrieval line. Default, probably dorsal, because it's out of your way. You can also go sternal or anywhere else. OSHA gives some flexibility with that, but they do say you need some sort of retrieval line or tag line. This can also be just a line to help other rescuers find you if you go down. Does it have to be life safety or not? Well, it depends on the space. It can double as some sort of belay line if it's a vertical entry and you're staying right there, or a main working line. But either way, if you're going to do entry in a confined space, you can't forgo some sort of tag line, retrieval line if you go down. So, all important. Dorsal or sternal, doesn't really matter. And there are other devices that we can use too. The air monitors, like a 4-gas monitor, we don't carry. Hazmat carries those, but we'd want one of those with us as well. And then the stuff to package our patient or victim. We have a separate escape bottle with a regulator and a face face mask. This is for our victim. The victim doesn't need a communication bundle package. Yeah, we can hook their line in to a port. And they're ready to go too. Let's not forget about packaging devices, skeds, backboards, half skeds, spec packs, all that good stuff. That's just site setup using SAR, comm lines, and then donning the PPE, all the stuff that the entrant would need at a minimum to make entry. There you go.